What up, athletes? Whoop, whoop. All right, so here's the thing. Here's your warm-up. Go ahead and do it. Take a minute. May I remind you of the vertical line test? That may spark a memory. We'll see. Go ahead. All right, so I'm assuming you paused me. You're good to go. Vertical line test just says if I can draw a vertical line and I only cross through a line one time, then it is a function. If I cross through it more than once, it means that there might be more than one output for each input, which is no bueno in function land. So here we go. We see everything's going to pass that vertical line test except for what? Line T here, the vertical line. So which lines are graphs of functions? Well, that would be line AC, right? AC. You probably should put that little arrow above it. Then we've got line. Oh, they got names for the lines. I didn't see they had names for the lines. Well, excuse me. So that's going to be lines what? R, U, and S. T is not a function, so R, U, and S. R, U, S. Russ. Find the coordinates of the points on line R. What's the coordinates of A? Okay, well, this is my y-axis. This is my x-axis. A is at the point 0 on the x, but 1 on the y, so 0, 1, right? Just find the coordinates here, peeps. Find the coordinates of B. B's right here, which is going to be at 1, 2, and then 1, 2, 3. So 2, 3. Got to be able to find coordinates, so make sure you're able to find your x and your y, right? We always do x first. C is going to be, oh my goodness, it's all the way down to here, which is 1, 2, 3, 4, 5. So 5 on the x, 1, 2, 3, 4, 5, 6 on the y, so 5, 6. And that's how we do it. Okay. Also might help sometimes if you, what is it? Control plus. How do you zoom? I don't know. Maybe it's without that. All right, I'm going to erase this, make sure you have it written down. I think I have to have it in this mode, and then I can go control. There we go, make that a little bigger. Because it wants me to find the slope of line T and line S, okay? So we see line T right here. Well, okay, line T, all right. So the slope of line T, so for T, the slope of T is equal to, well, actually wouldn't write it like that. No, we would not. We would write the slope of T. That's how you would write it. Equals, remember it's rise over run. Well, that's infinite rise, right? And unfortunately it's over 0 run, which means no slope. I think one of the answers they might give you one day is undefined, but it's really no slope. All right. Now, what's the slope of line S? Well, it has 0 rise over infinite run, and you can have 0 on top. Just means I have 0 of the infinite, which equals 0, has a slope of 0. So horizontal lines have a slope of 0. Vertical lines have no slope. Awesome. Let's get moving on with this lesson. We got some stuff to do today. I'm going to control, minus myself back. Oop, I want to be at 100% though. There we go. All right, you do got some vocab, guys. I know it's things we have to do, so just take a minute, write all that stuff down that you need to write down, okay? Linear inequality, it's a half plane with a boundary that is a straight line. Basically, you know how we have those inequalities of like x is less than 5? Well, now we're going to mix that with graphing. It's not bad. Really has to do with dashed versus solid line. Not bad at all. Good stuff. We'll talk about it. But go ahead and write that down. Boundary, the edge of the, basically the line created by that inequality, right? And it's either going to look like that or dashed like this. That's the boundary. Closed half plane. Well, this is a closed half plane. Or, excuse me. Okay. All right. Closed half plane. that is, what does it say, the solution of linear equality that includes the boundary line. So if it's a closed half plane, it's going to be like, let's say, you'll get to this later, but there's going to be a solution set over here, and it includes this boundary line because it's a solid line. That's closed half plane. Open half plane, it means there's a solution set, and it has a dashed line, which means it doesn't include the values on the line. Okay, that's what it is. A constraint is a condition that a solution must satisfy. So in other words, it's just a rule for the solutions. Set of rules. But we'll get into all this. I know it can sound a little confusing. It's not too bad. In fact, I really enjoyed this stuff. All right. Pause this. Make sure you have it all written down. We're going to roll. Move that timer out of the way. Okay, I want to talk about graphing by using a table. We're just going to remind ourselves of graphing. Now, most of the time you're going to get things in the y equals mx plus b form, but you may not. And all graphing by using a table means is we're going to plug in an x. Remember, x is our independent variable. It's our input. And then we have our dependent variable, which is y, which is our output. So we're going to plug in -3 for x. And so for x minus 2y minus 7 equals 0, I'm going to get negative, oh, I got my draw tool, -3 minus 2y minus 7 equals 0. Okay, I can combine the -3 and -7. I get minus 2y minus 10 equals 0. I'm going to add that 10 to both sides. We're just solving for y, right? And I get minus 2y equals 10. Divide both sides by that -2, and we have the y equals 5. That was supposed to be a 2. That was terrible, though. And -5, excuse me, because it's a positive divided by a negative. So we know it's going to be -5, right? Awesome. And then let's do this next one. And we're told this is a line, by the way. We know this is linear. It's x and y only are to the first power, so it's a line. And that's going to be good for us because it means it's going to have a solid growth value. -1, we're just going to plug -1 in. -1 minus 2y minus 7 equals 0. And we combine those, we get minus 2y minus 8 equals 0. We can add 8 to both sides. Minus 2y equals 0. Excuse me, 8. Divide both sides by -2, and we get that y equals -4. Now, can I make a suggestion? This is kind of cumbersome, right? This is not going quickly. So let's do this. Are you ready for this? So I know this is -5, -4. I'm just going to put these in. -5. Ooh, I'm in. Totally be done. -5 and -4. Here's a suggestion I make. If you're ever making a table, guys, solve this for y. What do I mean by that? I mean, let's solve it for y. So if I have x minus 2y minus 7 equals 0, you'll see why. It's really nice. Then I'm going to subtract x from both sides. Minus x. And I'm going to add 7 to both sides. Might as well do 2 steps at once. I get -2y equals -x plus 7. Then I'm going to divide both sides by -2, and I got to divide each term. Divided by -2. Divided by -2. And what do I get? Well, negative divided by a negative is positive, and that's just y equals half x plus, or excuse me, minus, I'll do that, minus 7/2. I'm going to leave it like that. You can make it 0.5x minus 3.5. I don't care. Well, I might do that actually. I like that. Let's scrub these. So 0.5x minus 3.5. That looks easier to me. And now check it out. When I plug in my 1, I'm just going to have 0.5. Y equals 0.5, right? Y equals, sorry. For that 0.5 times 1 minus 3.5. So what's that going to be? 0.5 times 1 is 0.5. 0.5 minus 3.5 is 3, so this, or negative 3, so this equals negative 3. See how much easier that is? And I can just go negative 3. Y equals 0.5 times 3 minus 3.5. So that's 1.5 minus 3.5, which is negative 2. And I think we can see as this grows by 2 each time, this is growing by 1, so this is going to be negative 1. You can also see a growth fact, the growth factor in there and know how to grow by. So there we go. All right, I'm going to delete this, pause it if you need to. Let's roll. This should be negative 3, negative 2, and negative 1. Boosh. Okay, so we're going to start off at negative 3, negative 5 to graph this. So I'm going to go to negative 3, negative 5. Oh, is that point right there? Okay, we're going to add another point because then it's going to go to negative 1, negative 4, negative 1, negative 4. So it's up 2, or up 1 over 2. I'm going to use that to my advantage. Up 1 over 2. See how we can just see that nice growth there? Up 1 over 2. And when we're done graphing everything, we can just say, all right, let's make a line. I'm just going to do it for my furthest points. Boom. And you would just do that with the ruler. Look at that. Isn't that nice? Right there. It's because I didn't put an extra point. I should have gone to 5, 3. Fine. I'm sorry. 5, negative 1. There we go. Is that better? Are you happier now? There we go. It's because I didn't put that last point. Even though you only need 2 points to define a line, but it wanted you to put them all. So that's graphing using a table. All right?